problem 2, 3, 3, 6, and 7 right now for all of you. So let's just begin with everything that we know. We're going to start with SUVAT, S-U-V-A-T, the letters. So the initial velocity is 4. After 6 seconds, the final velocity becomes 12. And we want the displacement of the body after 6 seconds. So let's be clear. One thing that we don't have is the acceleration. I know we want the displacement, but since we don't have the acceleration, I'm going to do something unusual. I'm going to go ahead, v equals at plus u, and I'm going to go ahead and actually solve for that acceleration. So we have 12 equals a times 6 plus 4. Now, let me rewrite this here. It's 12 is 6a plus 4. We will subtract 4 from both sides, and that's going to get us 8 equals 6a. So 8 equals 6a. We'll divide by 6, and that's going to give us a equal to 4/3. If you put that in your calculator out to 1 decimal point, that's going to be 1 meter per second squared. Now we can finally get the displacement. That's going to be s equals 1/2 at squared plus ut. Taking our values, s is going to equal 1/2 times a, which we got as 1.3, times t squared, which is 6, only square the 6, plus 1.3 times 6 right here. Then when we run all this in our calculator, we're going to end up getting around 47.4 meters. So that is problem 4. And I meant to say that that was problem 3, not problem 4. Moving on to problem number 6, let's go ahead. A car accelerates to 28 meters per second in 9 seconds. Find the distance it travels. So here we go. I will say s equals 1/2 at squared plus ut. And let's just assume it starts from rest since it doesn't tell us. So let's write out the SUVAT equations. SUVAT. S is unknown. U is 0. V is 28. A is unknown. And t is 9 seconds. So let's plug in what we got. We have s equals 1/2 times a times 9 squared plus 0 times 9. So we have s equals 1/2 times a times 81. Uh-oh, we don't have a. So let's do v equals at plus u to get a. 28 equals a times 9. And so a is going to equal 28 divided by 9. And that's going to give us about 3.1. Excellent. Now we can substitute into here, and we will get s equals 1/2 times 3.1 times 81. And that's going to give us roughly 126 meters. Finally, we have a particle that has an initial velocity of 12 meters per second and is brought to rest over 45 minutes. We want to find the acceleration of the particle. All right, so we have v squared equals u squared plus 2as. Why did I choose this formula? Because no time was given. So I figured maybe that's the way to go. Let's write out the SUVAT. S-U-V-A-T variables. S is 45. U is 12. Brought to rest, that implies V is 0. A is unknown, and T is unknown. So here we go. 0 squared equals 12 squared plus 2 times A times 45. So we're going to get that 0 equals 144 plus 90 times A. We'll subtract 144 from each side, and then we'll divide by 90. And so A is going to end up equaling negative 1.6 meters per second squared. So that is questions 3, 6, and 7.